earlier session. My earlier session was talking about recipes and got everybody hungry. So at this point, right before lunch, probably isn't a good idea to do that. I do want to make sure we move quickly through the presentation. We're going to be talking about SignalR and Reactive Extensions. So usually the first half of the presentation's on SignalR, second half of the presentation's on Reactive Extensions, and the third half is how you put these together. So we'll try to make sure we can fit all of this in together. My name is Jim Wooley. I'm a solution architect with SignalR Consulting. We're a national consulting firm with a local model, which means that most of our developers and such are working just in your local markets, aren't traveling around all over the world as compared to some of the other big consulting firms. And we do actually have an office here in Philly area. It's been open for about 2 years now. So if anybody's interested in talking to me about consulting, either needing consultants or being a consultant, feel free to see me after lunch or at the little party or whatever, and I'm happy to chat about that. Enough of the sales pitch. What we're talking about today is getting pushed with SignalR and Reactive Extensions. Most of the samples are already available online. I did actually update one of my samples about 30 minutes ago, so hopefully the demo gods will be good to us today. And that one is not available yet on the GitHub, but I will be pushing that out a little bit later. The GitHub IO account is for a bunch of my other presentations as well, so if you'd like what you see today and you want to go ahead and check out my other resources, then feel free to check those out. Contact information, my website, thinklink.com, Twitter alias @JimWooley, so you can go ahead and tweet how great this presentation is going to be right now. Don't wait till the end. Yeah. And I don't put it on my slides anymore, but my email address, if you want to email me for whatever reason, is just between you and me and nobody else in the world, is jimw@slalom.com. So you can feel free to contact me and I'll get back to you with what I can. So today we're going to be talking about getting pushy and push notifications and those kinds of things. So what do we really mean by that? Well, in the, okay, my presenter mouse not wanting to function, so I'll have to come over here and see if I can get this to function. There we go. Okay, so when we're talking in the web world, traditionally HTTP has all been about pull. So I want to get a page, I want to get something data off of the web, then I issue a request to get that, and then it gives me back the results, and we are able to work. And then if I want some more information, then I have to ask again for it to give me results, and then I wait, and then it gives the results, right? That's the typical web-based model of coding. And so that works fine, but there are times where that comes to be a challenge. There are places where you might want to actually get notifications when something happens on the server and not have to wait until you re-request information. For example, if you've ever, right now with the basketball tournaments, for example. Basketball tournaments, you get scores more frequently, so it's a little bit different as compared to one of the big things we have down in Atlanta right now is soccer. And soccer, you don't have that many scores on, right? And so if you think about something like CBS Sports Watch, where it's updating the scores in real time, right? And that's fine. So everybody then, what we traditionally do would be to request every 5 seconds. Is it another score? Is there another score? Is it another score? But then consider, how do I scale that out to millions of users consecutively, right? Particularly in something where it doesn't update that often. And so that's where some of these push-based technologies will come into play, so that the server knows when there's something new and can tell the clients, hey, something is new now, you can go ahead and do something with that. So one of the ways that we're able to do that is using something like WebSockets. WebSockets are great. This is a can I used from a little while ago. It's been updated since, I'm sure. But this shows sort of which platforms can actually use WebSockets. WebSockets was new HTML5. And you'll notice if you're using IE8, if you have any customers who are still on IE8 or older Android browsers, for example, then you can't use WebSockets. So if you coded your entire application to only rely on WebSockets, what happens when you don't have those customers? Do you just not care? Which is possible. Or what happens if maybe there's a new technology, like HTTP2 comes out with some sort of a push technology, which you might want to be leveraging instead of WebSockets, and you built your entire infrastructure around a specific implementation. Is that necessarily something that you want to rely on going forward, right? So that's where a platform like SignalR comes into play. And SignalR is an abstraction over the communication mechanism. So that with SignalR, what you can do is you can push a request to say, register for messages that are going to be coming out, and then any time that the server actually wants to give a response, then it can just keep on giving responses and send that information out, right? And by default, this is probably going to be using WebSockets under the covers to establish the connection and then send the stream of information out over WebSockets. But if there's a disconnect, if the server doesn't support WebSockets or the client doesn't support WebSockets for whatever reason, for example, on the server, is anybody still supporting a version of IIS before 8, 7, 6, or something like that? Well, with 7 and 6 don't support WebSockets. And so what SignalR is able to do is dynamically at runtime figure out on the client side, do you support this technology? On the server side, do you support this technology? Great, we're going to party on the best solution that we have. If not, let's see what we need to fall back to and go ahead and work that way. The great thing for you as programmers is you're programming directly to the business logic and what does the business actually need. You don't have to care about the communication protocols at that point, right? So in this particular case, if we have various servers, ASP.NET servers, this is specific to .NET servers. For SignalR, if you're doing this in Node, then you're probably going to be using Socket.io. Is a good abstraction layer at that point. So we're probably primarily going to be working on the ASP.NET servers, self-hosting, Owen, things like that. I am going to be talking some about SignalR Core as well. And so you have additional servers there that you can deal with in SignalR Core. And then your client can be JavaScript clients, can be .NET clients, they have Objective-C, Java clients, and those kinds of things as well to be able to work on both sides. And so if you have WebSockets, most likely it's going to leverage WebSockets. But what if you don't have WebSockets? Then it's going to support long polling. What's long polling? Long polling is I issue a request, and I keep that request open until it gives me a response. As soon as it receives a response, I immediately turn around and issue another request. Okay? And so it's that turnaround and re-request that's probably going to be happening. For example, if you who have a version of IIS 7, it's going to be doing long polling. Watch out, though, with long polling, you're going to find that your server memory is going to shoot up because you're going to have a lot more connections that are going to be hitting in there rather than a single connection that's going to stay established and keep going, right? Heartbeat essentially means that I'm going to set up a timer, and every 5 seconds I'm going to issue another request and give me whatever happened in those 5 seconds. Right? Server-side events are going away for SignalR Core, but they are still back there in the SignalR for the .NET side. Okay? So basic understanding of that. So probably the best thing to do is to jump into a demo. Anybody seen SignalR presentations before? And you've probably seen chat, right? Do you mind if I don't do chat? At least not for this piece of it right now. I might come back to chat in a little bit later. But what I'm going to do is something a little more complex because I wanted to do an example where I'm sending out a lot of information. And how do we manage large streams of data over time? And so what I'm going to do is an example that's going to actually do drag and drop. So as I drag something around the screen, then it's going to send notification up to the server, and then that's going to echo around to everybody else to say, hey, here's a new position, move yourself around the screen as well, right? So a lot of points of entry and those kinds of things that we're going to have here. So how do we actually do that? Well, first of all, let's look at the server side of things. So we do need a server. This is not peer-to-peer communications. We are going through a server. I think that font should be large enough back there, yes. Don't know that I can make it any bigger. So this is a class. We have a class, we have SignalR installed. This is for SignalR for .NET, not .NET Core, but we'll see how they are very similar in the other way. And I'm going to have a drag hub, which is going to derive from hubs. The hub itself is part of the SignalR. You get SignalR off of the NuGet download. And once you download that and put that in your package, then you can derive from hub. And essentially dynamically then under the covers, SignalR will then find everything that derives from hub and know how to then share out those hubs. With .NET, it actually will pull all of the hubs in together into a single connection. With Core, you can actually specify that out and have different hubs for each one of your connections on the client side and server side. So we have an item dragged. With item dragged, it's going to then send in the positions of X and Y and do whatever it needs to do with that. So at that point, then, I'm just going to say the clients. And clients is one of the SignalR pieces that comes under hub. And under clients, I can then say, well, which clients am I going to then communicate to? I'm going to communicate to all of them. Well, the person who's dragging already knows where he dragged it, right? So you don't need to tell him again. So I don't need that one. I can do all except for specific user or users. And each user is going to have its own connection ID that you can then manage as well. I can also do it to an individual client or specific clients. I can do it to groups. So let's say we have a chat room, or we're playing a game, and each one of the games is separated out into its own group. I've also done a case where somebody wanted to know when somebody else is accessing this form. So I've set up a group for that form, and each person then comes into the form on a CRUD application, then can get notified that somebody else is working with this form as well, or this particular record, or what have you. So you can do something like that with groups. In this particular case, I'm going to do other, so that others is everybody except for myself, right? And I'm going to then tell the others then I don't get any IntelliSense here. But I'm calling a method on drag and passing in the parameters. It happens to be an anonymous type. I could use a full type if I wanted to. It could be a single value as well. But I'm now passing into that some onDrag method. Well, others itself is a dynamic object. If you remember back from the 2010 days, we had CSharp Dynamic. And with CSharp Dynamic, then, it allows us to call things on methods that don't even really exist. So here I'm calling into a method that doesn't exist inside of my C# code. What are we actually doing? We're actually going to be serializing the payload into a JSON object, along with the name of the method that we want you to call, and passing that JSON object over the wire through SignalR. On the other side, it's going to pick that up, deserialize what the method is that you want to actually call into, and deserialize the payload and call into that method. Whether that's in the .NET client, whether that's in a JavaScript client, whatever your client is, as long as they know how to go through that protocol, it's going to go ahead and magically make that happen for you on the other side. So that's most of the hub. There's one other piece of the hub that we need to also consider, and that is how do we actually register with MVC, for example, that we want to use that. And I believe in app start, I have it in startup here. I have this one app.mapSignalR. And so with that, it's basically going to go through our entire project, find everything that derives from hub, and then figure out how am I going to dynamically tell my client, depending on who my client is and what my server is, what the JavaScript is going to be needed to actually resolve this particular communication mechanism. You don't have to worry about that. It's all happening magically for you. Any questions about the hub? That's it for the server side. Well, this is an own host essentially, but you can do it as part of the MVC host, whichever way you want to do it there. It's pretty straightforward. I believe the SignalR core syntax is slightly different, but same concepts apply here as well. Okay, so that's that side. Now let's take a look at the actual view. So I believe I have this under, let's see here, index, right? And it could be just a plain HTML page with JavaScript. It doesn't have to be anything in ASP.NET, for example, but I just wanted to do this for one other feature. So here I'm going to have a view. It's going to have a shape that's an empty div. I'm going to size that to make it a little box, put some color on that, and then be fancy by having a move cursor whenever we try to move something around. The next thing is I need some JavaScript libraries. SignalR for .NET does derive from jQuery. They've removed the jQuery dependency for core. So if you don't want to put the jQuery dependency in there, then you don't have to if you're using in core. But for .NET, you do require jQuery. I'm going ahead and using jQuery UI just because it has an easy way to say something is draggable, but that's not required. And then I'm going to have the SignalR jQuery extension as well, and that's actually what's going to do some of the wire ups. And fourth JavaScript file that you need to reference is one that doesn't exist. If you don't include it, it's not going to work though. And this is the SignalR Hubs. It's a magic JavaScript file which is dynamically generated by the server based off of who the client is to figure out how we're going to resolve that. We'll take a look at that a little bit when we dig in under the covers moving forward. Okay, so now I actually have to implement my business logic, right? So on my business logic, I'm going to get a reference to the shape, and then I'm going to create a connection. And on that connection is the hub is going to be for my drag. Where did my drag come from? Right here. So we're dynamically resolving that. And then I'm going to say on the hub's client, whenever I receive an onDrag method, then do something with the values of that. Where is that onDrag method coming from? Right there. The dynamic method that was resolved, right? Okay, so then I need to start my connection, because if I call it something on the hub connection before it's finished initiating, it's going to throw me an exception. So I need to wait until I'm done to then say, okay, the shape, anytime you get drug around, then call into this function, which is I'm going to say with my hubs server, call the item drag method right here, and pass it your position. That's it. I'm done. Let's take a look at this in action. So I'm going to come up here and let's see if I can browse with. This is a nice new feature. Let's see here. There we go. Nice new feature that was added, I think, back in the 2012 days, to allow you to say, I want to not only browse with one browser, but let me take a look at it with multiple browsers, and let me set the size so that they can all appear slightly differently here. So this is great if you're doing side-by-side comparison browser versions, making sure that everybody's rendering properly and things like that. So let's go ahead and browse multiple of those. Looks like one of these did not want to resize for me properly. Let's go ahead and bring the size down on that one. It's thinking a little bit, trying to initiate. Theme song from Jeopardy is going through my head at the moment. Okay, and so here we have two green boxes, one on each of the browsers. If I click on one and drag it around, notice it's dragging on the other browser and vice versa from the other side. Cool? Hey, yeah, thanks for the applause. I appreciate that. Okay, so realize this is not peer-to-peer. The browsers are not talking to each other. Everybody's talking up to a centralized server, and then that server is then communicating the information down over the other side of the wire, right? So if we wanted to, we could take a look at the source on this, developer tools, and if we look at the network, let me go ahead and just reload the page so we see what actually came across in the network. And here we have our jQuery libraries, for example, and we should see, here's that hubs. I said that file didn't exist, didn't I? Well, let's take a look at what the hubs actually is. How about maybe the console, no, the debugger. I want the local host, yes. SignalR Hubs. Here is that JavaScript. And if we scroll down to the bottom of this JavaScript, you'll see things that look very familiar. So here we have a hub connection prototype, create proxies, register the proxies, disconnected. Here is the proxy, my drag. That name sounds awful familiar, doesn't it? Right? And we say, here's the client, here's the server, here's an item dragged function on that, and here's how it actually invokes. So if you're having issues trying to debug into SignalR, trying to figure out what's going on, take a look at this file, and you can put your breakpoints directly in that file and be able to navigate around a little bit more, too. Cool? Because it's not actually calling anything directly on clients. Actually, no, the client properties are actually being set over in the client itself. So it's overriding the proxy information on that side. Yeah. Okay? So that's a little bit behind the scenes goo. Now, there's actually a couple of interesting things, or one particularly interesting thing here is that, let's say I wanted to change that color. I didn't like green. Anybody have a color that they prefer over green? Blue? Okay, and if I save that, then I didn't actually touch either of the browsers, and now both of the browsers have it as blue. How did that happen? Huh? How did live refresh work, though? SignalR, actually. Because what's happening is when I use debug mode in Visual Studio injects another SignalR endpoint, and the server is Visual Studio. I said that that server doesn't have to be IIS, right? It can be self-hosted application. Well, Visual Studio is a self-hosted IIS instance, essentially, that's then pushing out SignalR information and allowing the browsers to communicate over the wire. If you then build to release build, it won't add that in. It's only if you're building to debug build that will add some of the SignalR functionality in there. And so that's sort of a cool function that allows you to do as well. And allows us to see how we might be able to leverage these in slightly different ways, right? Okay, so that's sort of the basics and beginnings of SignalR. Everybody cool with that? Easy to get started? Okay, so if we want to do a chat hub, for example, here's an implementation using a chat hub. Same thing, we derive from hub, we do send, and so we're just going to send to all the other clients. And then if we want a JavaScript client, we can have a JavaScript client for doing that. If we wanted, for example, a C# client, let's say we're in a Xamarin application, we wanted to have a Xamarin client that's resolving that. Really, the only difference in the code here is, other than the C# and the JavaScript syntax, is going to be, in this one, we have to tell it what the location is of that hub. Remember, in the JavaScript version, we didn't have to say what the location was because it was going back to the same server as the rest of the page was. Whereas in the C#, it doesn't know where the rest of that page is, so we have to say, and you're resolving from this other location instead, right? But pretty much everything else is pretty much identical from that. So let's say we, notice here that we have a lot of data that we're passing around. And that might become problematic if we have hundreds and thousands of connections. So how do we scale that out and get others to be involved with this? Well, a number of strategies, but sort of the baseline strategy is we have various clients, and the client then sends a message, and that message goes up to its server node. And what you would do now is you would add some sort of a backplane. And then when the message gets sent up, it then propagates out to the backplane, moves across the backplane, and then before the server sends communication out, it sends to the backplane, and the backplane then resolves that out. And then the server, through parallel tasks, then send that out to all of their clients, right? It's really complex. There's a lot of code that's involved here. I'm not sure whether you're going to be up for it or not, but here's your code. So you're going to add a NuGet package. There are 3 backplanes. There's a SQL backplane. There's a Redis backplane. Don't use the SQL backplane just because of the overhead that SQL has itself. Use the Redis one. And so once you establish your Redis connection itself, then you should add a NuGet package for the Redis backplane, and then say global host dependency resolve or use Redis. Tell it what the server port password is and what your actual example is, or whatever your implementation is. And then it's going to just go ahead and propagate that information all out there. Cool enough? Yeah. I'm not sure how, I don't think it would work over multiple Redis, but then Redis has to make sure that it knows how to propagate information out, right? Yeah, one endpoint for the Redis server itself, yes. Okay, now, but there's sometimes where you might need to resolve that strategy a little bit differently. So maybe when the initial connection comes in, let's say we're in a game room, and then you want to make sure that everybody in that game room then gets locked into a single server. So everybody can take the initial request, but then figure out how you're going to reroute it. So that's another strategy which you can do from scale out as well. But another thing you might want to do is maybe scale and say, I don't want to send all of my data. I only want to send parts of the data. So for example, in drag drop, I may not care every single minute position that's going through that operation. I only care maybe where the end result was. And let's filter out all the other things, right? Or do some sort of other programming construct as well. So we'll get to that in the answer to that one here in a minute. Let's take a look a little bit at SignalR Core. So the differences with the SignalR Core, and this was put in a little bit ago, so I need to update probably this slide. When I wrote this and all the demos, it was on the alpha version of SignalR Core, which came out sometime last fall. I think it's still in preview. I don't think it's officially final yet. So they are lagging back behind some of the other parts of Core. It replaced the global host with a dependency injection mechanism to be more equivalent to the rest of ASP.NET as well. So you can just inject that rather than having to access sort of a global location. They've found that there are places where originally when they did SignalR, it was going to be HTTP only. But there are places, particularly around the IoT space, where other protocols are important. And so they are extending to be able to support other transport mechanisms other than just HTTP. They are removing the jQuery dependency. They've dropped forever frame. They're allowing you to have a separate connection for each hub. And then they also have some additional client libraries. For example, there's a Swift client library if you're in the iOS space. They're also going to be supporting not only JSON packages, but binary packages as well. So being able to optimize the binary that gets sent across the wire. They actually had a demo from Build, I believe it was, where they had a webcam and using an IoT device that was taking the stream of images coming off the webcam, sending that over the wire. On the server side, then, I'm getting an echo here, aren't I? On the server side, translating that image into ASCII art, and then binary sending the ASCII art down to the other client so everybody can see what it looked like in ASCII art, just because they could, right? So some interesting spaces in there, and maybe some optimizations for performance as well from the binary data support. The link down at the bottom was the presentation that Damien and David did for Build of last year. It's a fascinating presentation just to see how they talk together. It's like a husband and wife that have been married for 20 years, the way they banter back and forth. And just fun presentation to watch, even if you don't like Signal or otherwise. So let's take a look a little bit at maybe at a SignalR core demo as well. So here I'm going to jump back over into Visual Studio. I've got a different sample project here. And how about if we take a look at the chat. So here I have a chat component, and I'm going ahead and leveraging Angular for this, but I'm not going to teach you all about Angular 2 in the time we have for this presentation. I hope you don't mind. Here I have my page. The page is going to have a text box that's going to allow you to input text, and then a button to send the message. Yeah, sorry folks, this is chat again, right? And then in my component is then going to get a hook into the SignalR client. And this is an NPM package rather than a NuGet package. The server is still a NuGet. And then I can have this message itself, which is what we're binding to. And then in order to send a message, which is what my button is going to call into, I'm going to figure out what the data is. And it's going to say I'm going to send this over on the other side. I'm going to then say we have a hub connection. The hub connection was very similar to the other one, although in this particular case I'm specifying which hub it is that I'm referring to. Remember on the other one I just said the hubs. I didn't need to specify which one it was. So it's going to have a separate hub connection for each one with core. Then I'm going to say on, anytime I get a send request, then we're going to receive that message that came over the wire, and then I'm going to push that into my messages array, which then is going to show that message on my screen. If I receive a message, or I'm sending a message, I'm going to call the connection invoke, and invoke the send message, and send that message. And then I'm going to start the connection, and then give some console output when I'm finished, and if I had any exceptions. Pretty straightforward JavaScript at this point. Even if you don't know Angular, you can probably figure out what's going on there. Question? Mm-hmm. Yeah, the SignalR Hubs. Yeah. So the question as a statement actually answers the question is in the affirmative, is you no longer need the hub connection, or the SignalR Hubs JavaScript library reference. It manages those slightly differently with the core. Okay? So what about the server side of things here? Well, let's see. I have that in my controllers. I have the chat hub. And so the chat hub, this should look familiar, right? Here we are deriving from hub. And on the hub, we're going to get the connection ID list, because one of the differences here is clients doesn't have an others. And so the solution is, I know what my current context ID is, so I'm going to send it to all except the current user array. And I'm going to invoke the send method. And this happens to be now async instead. Okay? pretty similar otherwise to exactly what we were doing before, right? So let's go ahead and try to build and run this one. Let's do it this way. Here's where I'm hoping the demo gods will be happy with me. And this is Angular 4, I think, in debug builds, so it does take a little bit longer to download all the Angular JavaScript libraries. I'm not webpacking them for the demo's purposes here today. Okay, I think you have connected. Are you going to actually show me a page? Come on, you can do it. I have faith. Ah, yay. Okay, so here we have, Zoom's a little different between the two of these, but if I type in hello world, you see that it then echoes that over up to SignalR and echoes that back on the other side. Notice that the text is a little bit different. That's because when I sent it, I decided that my client already knows it, so it's not going to know it was sent. So it's going to say, I've sent this, and my then client says, well, I received that. So hi there, and able to chat back and forth, right? Okay, so able to do this both in SignalR Core and in SignalR. There's small minor differences, but otherwise, if you've done it in one, you can probably figure out how to do it in the other one fairly quickly and fairly easily. Again, it was still in preview build, so it's very possible that the syntax will change. I can't guarantee that I'll necessarily update my samples with the new syntax, but I figure that sometimes it's the best way of learning is by finding something that's broken and trying to fix it. So I'm going to leave it broken on purpose. You can believe that on me? And I do accept pull requests on my GitHub repository too. So if you're able to fix it, feel free to do a pull request on that, and I appreciate it. Okay, so I had a question over here? Mm-hmm. So the question was, do the client libraries handle making sure everything is wired up before you do anything? Essentially, particularly around the Angular binding itself, and Angular 1's digest cycle and Angular 2. I'm not going to get into the differences of how Angular 1 and Angular 2 bind stuff, other than this won't necessarily wire up until that binding is complete. And it's the binding that we're working with there is just whatever Angular 2's native binding is. You do have to make sure that you're watching until the hub is finished being created until you call something on it from a SignalR perspective. That's the one step of that I know that you have to watch out for. So I think the rest of the conversation is something for over lunch, right? Okay, so let's say we wanted to then do programming over these kinds of things, right? We have information that's going over the wire, and we have points both on the server side and the client side that we might want to do additional logic on. I already mentioned a little bit about maybe we only want to filter and only want to see it when it's done moving, for example. So what are traditional programming models that actually work against that? Well, one, we've been using event-based programming for years. So for some of us, maybe decades. I see a couple of gray hairs out here, or a couple that don't have as much hair at all, right? So events are one way of doing it. Callbacks are basically a part of a way of implementing event handlers. We also now have promises. We have async and all these kinds of things. And these are typical ways that we would be able to accomplish that programming model over the syntax, right? But there's some challenges that we run into using these kind of programming models. One is, anybody dealt with that nested callback hell, where you get indented in 20 levels deep on a callback and trying to figure out what was that callback for? And of course, you probably should refactor your code a little bit more and use a more functional kind of programming syntax for that, but that's sort of beside the point. The other thing is, think about an event. How do you cancel an event? Let's say we're issuing a web service request and we have a callback. How do you cancel the request? You don't, right? But maybe you want to. Let's say somebody's typing and they stop typing, and so you send a web request off and they start typing again. You want to say, well, ignore that request and let me go ahead with whatever the next request is when they're done typing again, right? So cancellation is an issue. How do you unit test an event? You can mock the object that has that event and then explicitly call that event handler maybe, but that's really nasty, right? And so these are some typical problems of dealing with this kind of communication mechanism. And so Microsoft was looking at a lot of the various programming APIs, looking at various scenarios, various patterns, and trying to find what makes sense to be able to program against those and solve some of these fundamental problems. And they looked at a lot of them. And one of the ones that they were looking at was also trying to solve how do we query things of data that's happening in real time. So not just querying a database, but how do we query a stream of data that's coming in? Well, querying, they had this great concept called LINQ. I loved it so much that I wrote a book on it. But it was a great pattern, but there's a challenge with this pattern in that this is a blocking call. Anytime I call move next and current, it blocks until we actually get the result. So if move next calls another service off to an external service, then is our UI blocked when we're iterating on a for each until it returns that result? That's probably not a very good experience, is it? And so they looked at a lot of these patterns also, and they found one which, pub/sub or observable, which actually does this kind of thing. And so they looked at it a little deeper, and they said, and this is where everybody didn't understand. They said that, well, if we actually take the inputs and the outputs and we flip them, these are actually the same. And so then, based off of lambda calculus, we can say that anything that we call on one, we can call on the other. And using the same programming model for one, we can use on the other one. Right? So here we have the on next, which goes to the move next, and that returns current, or passes current in. And then the Boolean from the move next is the uncompleted. And then, oh, by the way, we can have an error condition as well, which this doesn't even account for, and nobody uses reset anyway. Right? So we have a programming model that we can use against one, maybe we can use against the other one, and that's where reactive extensions comes into play. This is sort of the Twitter definition for reactive extensions. It's a library or set of libraries for composing asynchronous and event-based programs using observable collections. So that's a mouthful. Asynchronous and event-based programs. We're pretty familiar with those. We've been doing those for a while now, right? We can grasp that. The observable collections, I'm not talking specifically around observable collection of T. What I'm talking about here is a more broad concept, which is streams of data that are happening in real time, where not only the data is important, but potentially the time-based element over that is important as well. Okay? And then the composing is the ability to build more and more complex structures that are able to aggregate over various streams and pull those streams in together, right? So if we had just a single stream of data with a single async, for example, it's not that interesting. But if I start to have, let's pull in a stream of data from the Federal Reserve along with the stock tickers, along with the bank rates, along with CNN or some other news feed, and have an aggregation system that can say in real time, hey, go buy this stock now, that might be compelling. How do you write something like that? Well, that's pretty complex. But it would be nice if we could say something. And no, I don't have that demo, I'm sorry. But it would be nice if we have something like that. If I had that demo, I probably wouldn't be making $1 million and playing the stock market rather than being here and speaking in front of you today, right? So here's where we sort of have SignalR and RX then starting to come in together, where we can then say, well, send the connection out to the SignalR, and then in the SignalR, either on the client side or the server side, then we can transform, maybe map, filter, select, drop things out, and change what the values are. Maybe we're not going to actually go as far into the connection as we do, but maybe that connection continues on and we transform it out to various other options and some of those kinds of things. And that's where we get the two of these sort of playing in together, right? The syntax is a little different depending on what language you're working with, but almost every platform and every language today has some sort of a reactive programming mechanism. It's not just C#. Originally, the first place that reactive extensions came and was shipped was with the Silverlight 3 toolkit. That tells you about how far back it goes. And why did they ship it? For gesture support and unit testing. Okay? So with gesture support, think about if I were to move my phone and shake my phone, right? How do I know when I have a shake? Well, if I move my phone like this, is that a shake? Probably not, right? We're just moving it. I have to have some sort of an acceleration which is large enough that is going to say it's aggressive enough, right? Is that a shake? I say probably not. That's like a knock. Just a single hit, right? So if I do that, is that a shake? I'm going to say probably not because the time-based operation between the two of those is not close enough together. So I'd say that's minimum for a shake, and that's still one shake. Now, how about if I told you I can do basically a link query over the accelerometer, which is only 5 lines of code to actually determine all of those states? I've got a blog post on that one. I'm not going to have time to show you that one today, but it's a pretty aggressive programming model. So let's take a look at a little bit of what we can actually do with some SignalR. How do we, our reactive extensions, how do we get started with it, and what are some of the kinds of things it can do? So I'm going to start off with a really simple example. This is a typical enumerable. We're going to have a range of 1 to 10. I'm going to filter out only the even numbers. I'm going to impose some time delay just to impose some sort of an asynchronous process, say something is happening. And then we're going to for each over those and output the results. Now, when I do this, notice when the done, you can continue working happens. So if this was a UI that's not doing these things asynchronously, then we're not going to be able to actually do anything in your UI, even moving the form around, for example, until that done happens. So let's go ahead and run this one. I'm happy to use LinkPad. LinkPad's a great little tool for playing around with some C#. It doesn't have to only be link, but okay. So you saw how long it took for us to actually get to the done state, right? Maybe not the most optimal kind of construct here. So what if we change this to go to an observable rather than enumerable? There are plenty of different factory methods to actually create observables. One is to say observable.range. And I where, and notice that query now says, yeah, there's a problem in query in the for each because really for each is sort of antithetical to listening and responding to events. So instead of doing for each, what I'm going to do is I'm going to subscribe. And on that subscribe, I'm going to take the num and then do something with the num. It can either take a full observer, or I can take the individual lambdas of the parts of the pieces. So on this function, I'm going to just go lambda function and say we're going to right line that value, right? And so now if I run this, what's going to be the elapsed time? Well, the elapsed time will probably be 0. This is not going to wait for the things to be done, so I don't know what the elapsed time is going to be. I need to actually pull this elapsed time in here and do the onComplete. So when it completes, then I'm going to say what the elapsed time is. But it's very possible that it will never complete. Think about if this is a heartbeat monitor. I would hope that during the time of the presentation that I'm standing in front of you today, that my heartbeat monitor is not going to onComplete on me before the end of the presentation. I'm just saying, right? So it's very possible that we may not get an onComplete. I do need to say, since this is actually working on the, I do need to say that I need to observe on the task, let's see here, task pool, scheduler default, to say that I actually want this to work on a background thread rather than the current thread. And you have fine-grained control over those. So why didn't I like that one? Not like the first one. Well, let's try it anyway. Yeah. No, it shouldn't, or at least I shouldn't. I never have before. Oh, I did the task scheduler rather than task pool scheduler. Okay. So now if I run this, notice immediately I say done, and now it's going to issue the request as it's moving up the stream. Okay? So I didn't change the logic of what I was doing. The business logic stayed the same. I just changed some of the implementation details of how I was subscribing and triggering these, right? That's one of the fun things, great things about this. Now I can extend this and do some more interesting things. In this particular case, I'm going to get a sensor. This is an observable stream. How the sensor generates its information, I don't really care about. I'm just going to do things over that sensor. This could be coming from an IoT device. In this particular case, it just happens to be generating random values over random periods of time, right? So one of the things that I can do is I can say, well, dump latest, which is a link pad helper, which just sends out all the values. And in this one, I can say, from essence sensor, where the sensor value is less than 3, then select out the S. Now, even if you've never seen Visual Basic before, you can probably figure out what that code's doing, right? It's only going to output the sensors where their value is less than 3. What's a 3? Doesn't matter, right? That could be the ones where the airplane's about to go into a nosedive. You might care about that. Here's one where I'm doing where the sensor type is 2. So that could be the blue sensors. I don't know. Doesn't really matter which one. This is a little more fun one. Anybody figure out what this is doing? I'm not actually adding seconds. What I'm doing is I'm getting all of the ones that happen every 3 seconds. And I'm buffering those together. And so every 3 seconds, then I get another different count of how many of those things happened in that 3 seconds. And then I'm just going to multiply that by 20 to say, this is the approximate number per minute that I'm going to get. And I can update that every 3 seconds. Right? So heartbeat monitor kind of thing right there, right? And then I'm just going to do a small group by. Group is kind of interesting in that group by then returns an observable of observables. So every time we get a new group category, then that's an observable, and it has inside of its values what are the observables inside of that as well. Right? So if I then run this, we should see all of these running all at the same time. All of the values are coming out there, coming out pretty fast and smooth. If I take a look also at the results grid, I can see each one of the individual queries. Here is every 2 minutes it's going to update into a new value, and life's good, right? So you can see where this kind of a programming model is very elegant, and you can start to accomplish more and more powerful kinds of things by using a programming model like this. And it's very similar. If you know how to do link, you'll know how to do this. It will require you to think a little bit upside down more functionally. I admit that. Because link was the gateway drug to functional programming. And for me, reactive extensions is the crack. You really start getting into getting involved with that and being able to do some fun stuff with that. So now I have the ability to generate values, being able to filter those values, and doing other kinds of interesting things. There's actually one SQL statement, one common SQL statement that you're using against a database that you can't do here. Anybody have an idea of what that statement might be? Let's see, what do we have? Where, from, select. Huh? Search you can do. Which one was that? Event? Oh, having. Having is sort of a filter aware, right? You can join. Join's a little different in that join, to some extent, requires you to know what the full set is, because it's possible that I need to join to there. So they do have some join patterns which are like an interleave. They have map and flat map, or select many, right? That allows you to do things as they come over the wire directly. To do one where it's mapping in that way, it's a little bit different. So there are a bunch of, with reactive extensions, you'll see a lot of things around marble diagrams, which help you to visualize some of those relationships. So you can do joins, but joins are a little interesting in that regard. But there's another one. Count, you can count things. You know, another value comes in, now I have, increment that count, right? Order by, right? Because, you know, I send out values 1, 2, and 3 ordered. Now value comes in 4, and then value 4 should have actually been ordered the first one. Do I go saying, oh, clients, ignore what I just told you. I'm going to tell you the whole thing all over again. Or, you know, just insert that one up in the front. Just trust me that I know how you're going to do that, right? It's sort of antithetical at that point. So that's where usually these buffering and windowing operations, that's where it will return a list of things, and you can order inside of each one of those groups of the time-based components. It can either be buffering over time or buffering over a count. Those are link-pad, yeah. Yeah. They've changed the syntax of those. There was dump live and dump latest. Dump latest actually has superseded, and part of it has to do with how is it actually displaying out here. Yeah. 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 So it's a nice link pad has some interesting extensions there for observables as well. That's one of the reasons why I went ahead and did it that way. Okay, so good so far with reactive. I know I can't go too deep with these, but now I sort of wanted to go back and take a look at, well, how do we then pass these reactive extension information, however we're doing that, over the wire, and push that information back down to the clients. So let's take back a look over at the, let's see here, I'll do this with the old SignalR version, I guess, for right now. Or, yeah. Okay, so here is, again, the first demo that we had, or first project that we had, a solution, and I have a sample down here, which is in the SignalR web, and on SignalR web, then I have my app code, and I have an observable sensor hub. Okay, so I need a hub, right? Okay, this is about the simplest hub you can possibly create. I have a class that derives from hub. Done. Let's move on. And then I'm going to actually start up an observable sensor. And this observable sensor is going to generate values randomly. This is the same code that actually was generating those values over in LinkPad. So I'm going to say I'm going to start out with 0. I'm going to always continue running. And anytime I iterate, I'm going to get a random value. And then on my result selector, I'm going to create a new sensor data object and set values inside of that. And then from time, every time span interval here from that random value, I'm going to then send out to the next value. So randomly, I'm going to say when the next value is going to come. And it's just going to figure all of that. So then I can do a link query over here. I can say only show me the 2s. I can say only show me the low values, whatever I want to do. Join it with something else. And I'm subscribing. And here I'm going to say the global host connection manager, get the hub context for the observable sensor hub, and on it, call it all a broadcast method. Again, that's that dynamic method, and pass the value on out, right? So that's all I have to do to actually send values over the wire. If I wanted to then receive those, then here's my default implementation over here. Again, jQuery, hubs, and SignalR. And I'm going to get my connection. Anytime the client gets a broadcast method, then I'm going to prepend the value into my list and start the hub. So here, let me go ahead and set this one to start up. Go ahead and run it. And while that's booting up, I'm going to go ahead also and start up a little console application. Make sure start this console application as well. And this is going to subscribe into the same server and start new instance. And it's going to return values, but it's going to filter down and only get some of these values, not all of the values. So it's only going to be getting the low values. So we should see it responding out values when those values get to be low on the other side. There we go. See the 0 and the 3. Here's the 0 and the 3, right? So what's the difference between the two of these? There's sort of two main differences here. One being we had to tell it what the server was, and the other one being here's where the server is, and here then I'm saying, well, filter this to only give me the ones that are lower than 5. Straightforward and easy enough, right? Okay. If I was doing this in JavaScript, where would become filter, and select would become map. The names change, but the general concepts still apply, right? And select many becomes flat map. So, good so far? Now let's say I wanted to do the chat implementation, and instead of on chat, having a button that says, well, invoke this when I actually call into that, then let's see if I can pull my chat one up here. Go ahead and stop that one here. Okay, that's in one client. Here's in the other client. Let me get my menu because I'm going to change over to the reactive chat. And reactive chat. So here, notice I don't have any button, but if I can start typing in this one and say, this should send a chat when I chant a chat when I'm done. Notice I didn't have to hit an entry button at all. It knew when I was done typing and only sent it when I was done typing. Okay? So how did we do that? Well, let's take a look over at the other sample here. And that was the one which I finished coding about 10 minutes before the presentation. So demo gods must be happy for me today. So here I have my reactive chat component. In reactive chat, I'm leveraging in Angular the ability to have reactive forms. And so with this one on my input box, notice I don't have any ng model. I have a form control name, right? And in the app module, I've pulled in a reference to the reactive chat, or the, not the reactive chat component, where's reactive forms? Right here, reactive forms module from Angular Forms. Again, I'm not going to get into the depth of Angular itself. There are a lot of tutorials around that, but I just wanted to give you an idea of what you can do. So in the reactive chat component, then I'm going to have a form control, which is from Angular Forms as well. And on that form control, then I can, amongst other things, get value changes. Value changes is an observable. It's an RxJS observable. And with that, then I can call any of my RxJS methods. For example, I can say, if they are changing from one value to the same value, then I don't want to send that on forward, right? I don't need to send the same thing multiple times. I can also say, well, debounce, in other words, wait to say if there's been a half of a second that's occurred, and if they're still typing over that half second time, then restart your timer automatically, and let me know when a half second happens where something hasn't happened. Think about the code that you'd have to write in order to actually do that yourself. It's pretty significant, right? And then I'm just going to subscribe with that value here and send that value out. Now I could, for example, add in here that I want to filter and for t, then if t equals foo, then, or not equals foo, probably, then only get the ones where it's not equal to foo. And so that way I can say, well, certain text strings, profanity or whatever you want to do, don't send profanity over, but you can send anything else out over. If they try to put an emoji in, don't send the emoji out, whatever you want to try to do there, right? So you can do a question. Mm-hmm. So the question was, could you put like a ... when somebody's typing, so that they know immediately that somebody's typing, and then when on the debounce, then do the other? Sure, you can have multiple subscriptions. So I could have the message value changed, have a subscription for sending the ... that something is happening, and then have the other subscription say, and when it's debounced, then pull the dot 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 off and send the actual value at that point. Mm-hmm. Yeah. Yeah. So can you have a non-debounce and a debounce? You know, when did we start and when did we finish? Right. Yeah. So yeah, there are ways of doing that kind of a thing there. But good question there. Okay. And so just to send the messages, then I'm just or receiving the messages. This is the same SignalR at that point. Sending the messages is the same SignalR call to invoke the messages on the other side. The only difference here is then I'm hooking in a client-side observable as well as a server-side observable in my JavaScript. And the amount of code that you have to do is relatively minor there too, isn't it? Question? Yep. So the question is, can you hook an observable up to the stream that's coming out from the server? And that's actually what I have here, is the hub connection has a stream, and actually my stream sensor information is passing and it returning a iObservable of sensor data. So this is an Angular version of the sensor demo that I showed you before. So on this one, it returns an iObservable of sensor data, and I could easily say on here, over that stream, then filter for a value, and on that value, then if it's low value, whatever that type is, or sensor value, is less than 7, whatever that value happens to be, right? So yeah, I should be able to do that. I'm not quite sure why this is. Filter does observe on. Okay. This happens just after I say the demo gods are being happy with me. So, okay. Yeah, it's also Visual Studio TypeScript, and yeah. But you conceptually, essentially, be able to do this, or do a map and filter and flat map and map latest and debounce and all those fun kinds of things you can do inside of this. So we get the stream there. Yeah. Yep. So this happens to be Angular core, which has some of this new functionality, and particularly in terms of sending out these server streams. Let me see if I can get you the sensor hub from the Angular version here. Here, notice the return type is an iObservable sensor data. And so I'm not actually returning the subscription. I'm returning the actual original generated one. Yeah. Now, how you're getting that, where you're getting it from, that could be coming from an IoT device, right? It could be coming from whatever. As long as you can get that in, it could be coming from a web service request. You could be issuing multiple web service requests, and then as the results come in, then feed that on out, and some of those kinds of things as well. Cool? Now, all the code will be available on the GitHub, so feel free to, you don't have to take pictures and retype it in yourself manually. Be able to see the real thing out there and try it. Okay? So pretty easy to get involved with this. Now, I'll admit, the first time you try to write something in reactive extensions, you're going to bang your head against the wall. Notice I've done that a couple of times right up here. Because it does require you to think very functionally and flip the whole concept upside down. But once you get it, then it's really fun, the kinds of things that you can do. We've already basically looked through those. I wrote an implementation, this is years ago, for a customer that kept running for a while. And this was a self-hosted application running reactive extensions and SignalR and self-hosted web API, all of which were still in beta at the time. And I put that in the customer site. They loved me for that one. But this was, a long-running server operation that then we have various number of clients that can connect to this long-running server operation, and even then say, well, stop the long-running server operation, or inject something else into the process that the server's running, and show me as every time the server's doing something new. So if anybody, for example, have done like server build processes, and you see as the server's building, it's outputting console output essentially into the server window. I know Visual Studio does that now. The same kind of thing would be able to apply here. So using SignalR to push those over and then say, well, I only care about I don't want verbose, I just want warnings or something like that, and being able to filter those out might be another key kind of scenario here. What are the various flavors? As I said, originally, Reactive Extensions came out on CSharp with the Silverlight Toolkit, but since then, it has gone into almost every single platform. It was baked into the Windows Phone ROM, Windows Phone 7 days, but there's also Ruby, C++, Java, of course, RxJS, and this really took off with RxJS with Angular 2. When Angular 2, Google took a dependency on a library that Microsoft wrote in their platform. That wouldn't have happened 5 years ago, right? The RxJava is probably one of the most popular versions of Rx besides RxJS at this point. Why? One big company uses it pretty significantly, both on their client side and their server side. Huh? No? Netflix. Yeah. Netflix wrote the RxJava implementation for the most part. Now, again, the syntax is a little different for each one of the platforms to be corresponding with what more native kind of programming model is. So, for example, JavaScript already has map and filter over arrays. So why don't we just go ahead and use those same methods rather than using select and where in JavaScript, right? So the exact implementation might be different, but you see all of these various platforms have some sort of a reactive kind of programming mechanism at this point as well. I mean, it's more, is it a standard or is it just that they all have their thing? It's not a programming API standard because the names are different, but the concepts apply more standardly. Now, which methods do you have may be different from each one of the platforms, right? But the concepts still apply. So, where might you consider using some of these kinds of things? I already mentioned the sort of the heartbeat monitor. Think about a manufacturing facility that, as things are coming across and out of tolerance, that you might want to, raise the alarms and say, hey, there's something wrong. Gesture support in mobile devices, for example. Stock tickers and financial information. This happened to, I think this was when I did a presentation to someone that had a nuclear or a power energy facility. At one point I had the space shuttle on here. This was an interesting one where a couple of guys from Germany took about 2 months as part of a school project, and they took a Kinect and they put it on a helmet facing forward with duct tape and on a backpack and Bluetooth headset, and had set so that it could help the blind walk around. And all of the signals and such that were coming over, through that system were coming through reactive extensions and being merged in together to say, hey, there's a step down coming up in 5 feet. Right? So a cool way that we can actually change people's lives using technology here. Mm-hmm. So work queues and having that refresh whenever that happens in the browser, and maybe saying only show me mine or something to that effect, right? And so that's a great place where SignalR can come into play there as well, right? Like I said, I did one where it said in real time, anytime somebody accesses the same record, then tell anybody else accessing that same record that, hey, there's multiple people working on this, so that you don't, that whole pessimistic concurrency issue. I took, the customer wanted me to lock the record. I said, no, we're not going to lock the record on the web implementation. And so instead, I'm going to give you more information around who's actually doing what, and then let you actually interact on that one at that point, right? Which the customer found was very valid. And the person who implemented that on my team had never seen SignalR before, and he implemented the whole thing within 2 weeks. Even to the point where with SignalR, you can then be on the page, close your laptop, pull the plug, and go home. And as soon as you close the laptop, the other person knows you're no longer looking at that page. Yeah, good question. So how do you ensure that you get the message, right? So if you're in an industry and an alarm goes off, how do you make sure that somebody's actually listening to that? Well, one of the downsides with these kind of mechanisms is it doesn't persist the history. So it only cares about what's happening in real time now that I'm listening. So if it happened before I started listening, you won't know about it. So your application needs to handle some sort of persistence and the ability to bring back past information as well. Mm-hmm. Yep. Yeah. So how does this compare with a standard queuing mechanism, which then can persist and have reliable transactions and make sure that messages are sent? This doesn't really address that, but potentially what you could do would be have a message queue, which then feeds into a SignalR, which then passes the information along as well. And you have to sort of build that over the whole life cycle of everything else. So it doesn't solve that specific problem, and I realize that that is an issue. One of the things that SignalR version for .NET did was it actually did retain a little bit of that history and had an auto replay mechanism. Core does not have any auto replay at this point. And so it's fully on the developer to figure out how do I persist last 10 events, whatever is core to your particular business domain at that point in time. But good observations. Okay? Can you tell how many clients are connected? I believe on the clients you can actually interrogate that, because it actually, SignalR under the covers, keeps basically a GUID representing each of the users that are connected to it. And so that way you can actually manage into that. Yeah. Mm-hmm. Yep. Okay. Yeah, so if client drops, then does it reconnect automatically? SignalR.net does. SignalR Core does not. So it's up to you to be monitoring that with SignalR Core to say, I need to reestablish that hub connection if it dropped before. Whether that's going to be something that they're going to address in the future version of SignalR, if that's something that's really meaningful to you, I recommend posting on their issues list up on GitHub, because they're doing it in open source, and saying, this is significant, I cannot use your product until you do this, right? Mm-hmm. Yeah, if you use the regular SignalR, then it will do that reconnection for you automatically. Do realize that every time you change a page, you need to reconnect. So if you're doing a single page application and you have a single page application host, then as long as your SignalR is hosted inside of that, then you don't have to worry about the reconnect. But if you have a page navigation for anything else, then anytime you navigate to a different page, then you're going to have to reconnect that connection as well for SignalR. And that does apply on .NET at that point. Okay? Question? Sure. Oh, an interesting question, and unfortunately, I don't know the answer to that question. It might be a great question for actually sending to the SignalR team. They do have chat channels as well. I know they used to be using Jabber, which was a SignalR chat client that they built. I'm not sure if they are still monitoring that one or if they've gone over to Gitter or one of the other. I think they may have gone over to Gitter, but I'm not positive with that at this point. So this slide is more important if you download the slide, because all of these are hyperlinks to the underlying source information. Both SignalR and Reactive Extensions have free ebooks. Again, those ebooks may be slightly out of date at this point, but one of the great ways of learning is by going through those and figuring out, so now how do I do it in the new version? And how does that change? Because you're going to learn a lot by doing that. I do have a paper LI around Reactive, and that's not just RxNet, but all of the various reactive platforms, including Akka, for example. They're both open source projects, and so you can see the actual underlying source. And also, if you're on Twitter, the ReactiveX and David Fowler and Damien Edwards' Twitter aliases are good resources. This isn't as important as this slide because this slide gives you a link to all the other slides, and that's the one that you really want to get, right? So it also includes my contact information. Again, my email is jimw@slalom.com, so feel free to reach out to me if you have any questions. If you're trying to consider, does it make sense to use this technology for my use case? I'm happy to hear those various scenarios and try to think through, does it make sense, or just is a simpler model possibly better for you, or does this not make sense for whatever reason? So I'd love to hear what your particular cases are. We're at time right now. I know one of the best ways of getting a bad review is by holding people over lunch and not getting lunch, so I'm not going to do that, but I'll be happy to sit around and chat with you as well during the day. So thanks everybody for coming out. Huh? The slides are on that link right there. Yeah. Thanks for everybody coming out, and hope you have a great day.